So in this section, what we're going to do...
For the discriminant, we just find the discriminant and then test it in the program? Is that right?
So like as far as like a quiz, what should you be able to do? You should be able to answer questions like, what kind of roots do you have here based on the discriminant? So you calculate the discriminant, talk about the roots. Or, remember the example with k? Remember that example we ended class with? So if you have like kx squared plus 2x minus 5, and the question is, what values must k be for this to be imaginary roots? You have to set b squared minus 4ac less than 0. So that example, whatever, the second to last one, that was in the notes. Okay? From yesterday. Yeah, and any of those kinds of things. Traditionally, though, your quiz questions are pretty straightforward. The test questions are usually a little bit more, more involved.
Yeah.
So what we're going to do in 7.4 is we're going to take a look at equations that are in quadratic form, but they may not appear that way. All right? They may not look like a quadratic, but with a little manipulation or a little bit of change, you can actually write it as a quadratic. Let's first take a look. Look at these three equations here. What do you recognize about these three equations? Look at them and tell me what you recognize about them. Recognize anything interesting? Luca?
They all have a square in it somewhere.
They all have a square. Good. Agreed. That's one thing. What else? What else? There's a lot of things in similarity here. Shadows, feel free to chime in if you want to answer, by the way.
No, equals 0.
What is it?
All equals
They all equal 0. Yep. They're all set equal to 0. They all have a square term.
They're all subtracted by 10.
They all have a minus 10 at the end. All things true so far. What else? There's more. Nine.
They all have an x squared in some form.
They all have something squared in some form. Lucas started with that.
Oh, yeah.
It's all right. It's all right. Ben?
They all have 3 multiplied by something.
The middle term, there's always a 3 in the front as a coefficient. See the 3 straight up there? Look right from here to here. You have a 3 here as B, you have a 3 here, and you have a 3 here. So in reality, what do you have? What am I getting at? Say again? Yeah, they all have the same coefficients. If you have the same coefficients and it's a quadratic, it's really all the same thing. Except in the first one, you're solving for x, right? In the second equation, you're solving for the quantity 2x plus 4. And in the third equation, you're solving for the quantity 2 over x. Right? So solve the first one, please. Go ahead and factor the first one. What's the first one factor into? What do you got for this one? Yeah.
X plus 5 times 1, you have x minus 2.
Very good. So we've got plus 5 and a minus 2 here for sure, giving us negative 10 and positive 3. So as a result, we get x equals negative 5 and x equals 2 as our solutions. Now, the second equation would really have the same solutions because it's the same quadratic, except instead of x, we have 2x plus 4, right? Look at the second equation here, and instead of an x right here, we have a 2x plus 4. Instead of an x right here, we have a 2x plus 4. So we have an answer for x in the first equation that equals negative 5 and 2. But in the second equation, what would I have to do?
You just take x, negative 5 and x equals 2, and you get 2x plus 4 equals negative 5, and 2x plus 4 equals 2.
That's exactly right, Lucas. So what Lucas is doing is he's letting this expression, 2x plus 4, equal some dummy variable like u. Remember we did this where we said let u equal to make things easier? So for the second one, ready? Write this statement over here. Let u equal 2x plus 4. And this equation, as a result, becomes this. U squared plus 3u minus 10 equals 0. So you're defining some random variable that you make up. Doesn't matter. Call it w, call it m, call it the first letter of your name. As long as you don't call it x because x is already in there. So we let u equal that expression. We get this as a result when we substitute in a u for 2x plus 4 and a u for 2x plus 4. And if we solve that equation in blue, we're going to get the same results. right? We get the exact same factoring, and we get the same exact answers, but it would say u equals -5, and u equals 2. So what Luca did was he kind of jumped the step, and he said, well, since u is just 2x plus 4, and u equals -5, and u equals 2, then 2x plus 4 can go in right here, and 2x plus 4 can go in right here for u, because that's what u was defined as. So in the next step, all you need to do to solve the second equation here is say 2x plus 4 is equal to whatever I got, and 2x plus 4 is equal to whatever I got for the other root. Okay, so again, you go from your factor form, which obviously would have u in it, not an x, because we have u's here now as a variable. You get your two solutions, but since u was defined as some other quantity or some expression, substitute that expression in. That's why you learn about substitution method. This is one of the applications. And as a result here, we can now solve for x in both scenarios. Okay, what do I get if I solve for x in these scenarios here? What do I get, Cal?
-9/2 and -1.
-9/2, and then what else?
-1.
I didn't check these, so do others agree? -9/2 and -1? Yeah? Okay. All right, so again, look at the difference. The answers a minute ago were -5 and 2, but now suddenly, because we recognize that it's not x that's squared, but the quantity 2x plus 4, so our answer is not x equals something or x equals something, it's 2x plus 4 equals something. So the third one I'm not going to do, but what would the only difference be in the third one? In the third equation now. Instead of using 2x plus 4 equal to u, what am I going to do?
2/x.
Let 2 over x equal u. Again, 2 over x and 2 over x are there, so let u equal 2 over x. And then as a result, here, this would say 2 over x equals -5. 2 over x equals 2. So I don't have to do any of that work. I can jump straight to the answer. Now, how do I solve for x in both of those cases? This is part C, or the third part. How would I solve for x?
Multiply by x,
And then?
and then get it on its own from one side of the equation.
Okay, so what's the next step?
Divide that through. Or on the right side.
Yeah, that's fine. I was looking on the left side. And then?
Divide by -5.
Good. All right, so those would be the two answers for that third equation. So what I want you to pick up on is quadratics that aren't necessarily looking like quadratics at first, that can be manipulated or changed and thought of as a quadratic by nature. So look for a squared, look for a linear, and look for a constant at the end. Okay? Always look for something squared, something linear, something with a constant, and you can write it in quadratic form. Go ahead and try this one on your own. Base it off the last thing. Keep in mind that the 21 is on the right-hand side right now. So you have to start something else and then go to your use statement for this. Treat this like the last example you just looked at there. It'd be so much work to FOIL that out and multiply and then try and resolve. It's way too much work. So please, again, just move the 21 over and begin. Now, you should be able to factor these, but if they couldn't be factored, you could still use the quadratic formula, get your two results, and then set those results equal to 2x plus 1. So you don't need to be able to factor to do this method, but here you can factor. Right, what do you get when you factor this?
U minus 7 and U plus 3.
Good. Now, on the next line, I have my answers, right? U equals 7 and U equals -3. Ben, what do I need to do with these two answers now? Good. So we go ahead and plug in 2x plus 1 here and 2x plus 1 here and set them equal to those quantities. As a result, moving the 1 over, dividing by 2, we're going to get x equals 3 over here. Moving the 1 over, divided by 2, we're going to get x equals negative 2 over here. Okay, is the process pretty easy? This one's pretty straightforward, so it's not, very difficult to do. Let's look at ones that are a little more complex than just this. All right, so again, recognize the quadratic form in the equation. Let u equal whatever that expression is, and then move and solve. Did I make a mistake?
Yeah, I guess negative 1.
Where are we at?
On the right.
On the right? No, right?
Right. Oh, yeah, never mind.
Yeah, that's fine. Please, if I made a mistake, tell me. I know that happens. All right, example 2. Look at example 2. This one is a little bit complicated. The difficult part is the recognition here. How are you going to look at example 2 and think of this as a quadratic? Because it's definitely not a quadratic by looking at it, right?
Well, you square the whole thing, you get quadratic.
You square the whole thing. Be careful by that statement. You square the whole thing? You can't square the whole thing. I know what you're saying, Ryan, but the statement square the whole thing is incorrect. Because when you say square the whole thing, here's what I would do. And you can't do that. It's not going to work. But Ryan's on the right track. He has the right idea, but the way he's presenting it is not correct. What should we be doing here, Charles?
Isolate the radical x before you can square it.
We've learned that way in the past. Isolate x and stuff. Yeah, but you don't have to here, actually.
I just need to move plus and radical x over, and then you can square both
Say it one more time.
Could you move negative 7 radical x over, and you can square both sides?
You could try doing that, but that's way too much work. Again, recognize the quadratic form. Remember, guys, you're trying to solve it the way we've learned how to solve radicals, which is good. I'm glad you're doing that, but right now is not the instant for it.
Could you multiply by x the entire?
No, because if you did that, you get 2x squared minus 7x root x plus 6x. Good idea, though. I know what you're getting at. You're trying to get it to be x squared, right? That's why he said multiply by x.
Subtract by 6 and then square everything.
Yeah. Start with a let statement. What could I let u equal in this case? This is really weird. Go to the last problem. I'll give you a hint, okay? Because I know you can do it if you look at this. Look at the last problem. Okay, scroll back up in your notes. Look at your let statement.
Would u equal the square root of x?
Yes. Why, Nina?
Because then u would equal u squared would be the square root of x squared, which would just be x.
Yeah. So look at the last example. Look at the middle term. Look at the last example. Look at the middle term. The middle term had the quantity 2x plus 1 in it, correct? And isn't that what you let u equal? Didn't you let u equal whatever the middle term really was? What's the middle term here? Isn't the middle term radical x? Look at I'm talking about the variable portion, obviously, okay? Not the coefficients. The variable portion of the middle term is what you always let u equal. That's what it turns out to work out as. And Nina recognized that if this is true, ready? If that's true, then isn't u squared just simply x? Square both sides. Right? Square both sides of the first statement you made. You said let u equal radical x. Square the left, you get u squared. Square the right. Well, what's radical x squared? It's just x. So as a result, if this is true, u squared goes in for x. So u squared can go in up here. U can go in for radical x. So that u goes in right there. So you get 2u squared minus 7u plus 6 equals 0. Now, what you're going to recognize is that you'll get answers at the end, and then just to get x, all you have to do is square root it. Okay, so if you picked up on it in the beginning, you could have written it, and I'll explain in the beginning how to factor it, but try to factor it this way now. Is that the pipe that's making that noise right now? So we know it's going to be a 2u and a u. Yeah, it is. We know it's going to be a 2u and a u. What could the other terms be? What have you got for the other ones? I mean, 6 is either going to be 3 and 2 or 6 and 1. So 3 and 2 or 6 and 1. They're either both going to be positive or both negative. I'd say both negative because there's a negative here, right?
3 and 2.
Which way, Ryan? So we'd get a 3u here, and on the outer part we get a 4u, which gives us 7u, and they're both negative. Very good. Okay, so that's what we have now. So as a result, if we go to solve, we're solving for u. Okay, let's solve both of these for u, and then put in the definition of u to get x. So we've got u equals 3/2, and u equals 2. Well, u was defined as the square root of x, whatever that middle term, that middle variable term was. So as a result, we could just say radical x equals 3/2, and radical x equals 2. How do we get x? Anybody?
Square everything.
Square it. Okay? Again, it's not easy to pick up on this all the time. So what do you need to do a lot of when you go home? Seriously. Practice. This is the kind of topic where if you don't practice, you're not going to pick up on trends. You're not going to see familiarity. You're not going to see patterns, especially when it comes to taking something on like a test. This is a great problem for an SAT. The SAT is mainly basic factoring. They don't ask even advanced factoring. The factoring, believe it or not, is even less complicated. They never have a 2 in the front, which is sad. Factoring is real simple on the SAT. But it might not look like a quadratic. It might look like something like this, where you have to write it as a quadratic and then solve. That would be toward the end of a section on an SAT. Now, see the answers you got, 9/4 and 4? If you had recognized in the beginning the nature of this one, you could have written it like this. You could have written as 2 root x, what was it, minus 3, right? Was that what it was? And then minus 2, right? And then root x minus 2 equals 0. The same thing you have down here. See how these are the same things? As a result, over here you would have gotten radical x equals 3/2, radical x equals 2, which is really what we have down here. So if you don't need to write the let statement here, and you want to jump to factor this right into this, if you can pick up on that, because if you multiply this times this, you're getting back to 2x. This is going to give you a -4 root x. This is going to give you a -3 root x, making it -7 root x. So if you could have picked up on that factor in the beginning, you could do it that way as well. Okay, that works too. Let's see if I want to... A little bit tricky because it doesn't look like it's going to work at first. It doesn't look like it's going to work. What do I have to do here? And this is where I talked about you need to manipulate the equation sometimes. I need to make a change before I can write this in quadratic form. What change does that have to be? Hold on one second. What change? And think about this. Think about the fact that the middle term is usually what you let u equal to, right? But if you let u equal the middle term, which is 6/x, is that what the first one is? Can you put u in for the first one then? It's not. It's 3/x, right? So you need to make a change so that it would work. So that the middle term is your u statement, but it equals whatever the first term was.
Well, you can let it be u 3/x.
Yes, very good, Ryan. Awesome. So what Ryan recognized, and Luke, I saw your hand, I just wanted to get everybody in, is that you can take out a 2 here, like that, oops, and make this 3/x. Okay? And you can absolutely do that. That makes total sense. And now, as a result, 3/x is your u statement. And what Ryan mentioned was that you're going to have a 2u in the middle. So we let u equal to 3/x, giving us u squared plus 2u minus 35 equals 0. And again, solving. Okay, the solving part, this you should be able to do like that. Okay, 35 and adding up to give you 2. So 7 and 5 right off the bat, right? We're going to have a positive, so we want 7 to be positive, and we'll have a -5 there, giving us 2 answers for u. What's my last step? What do I have to do to actually figure this one out? Ben?
Oh, you didn't 3/x.
Kelly, how do I solve this?
You multiply both sides by x.
And then?
Then you would divide by -7/5.
Yes, so in reality, right, take a look. And you can, please, just keep doing this. Just switch these two. Switch x and -7. Switch x and 5. Because you're multiplying by x and then dividing by -7. You're multiplying by x and then dividing by 5. So whenever you have something where it's something equals a fraction, just flip them if the denominator is what you're seeking. So 3 over -7 is equal to x, and 3 over 5 is equal to x. Okay? The next one I want you to try on your own. All right, see what you get for the next one. Okay, your final answer is going to be really tricky, so spend a little bit of time trying to go through the whole process. If you're stuck completely, let me know, and I'll come by and give you a little head start. Okay, but again, look for quadratic forms. Move the 12 over. I'll give you that hint. Please move the 12 over to start. And then try to think of this as a quadratic. If you're stuck, look at your last problems and think about what you always let u equal. You always let u equal whatever that middle term was, so start with that statement. Think about u is equal to the middle term always. Start by letting u equal the middle term, if that works. If u equals the middle term, what goes in for the first term is commercial. Then down here, is about plus or minus, right? And don't forget, when you take a square root, you get your answer. So plus or minus 2 over plus or minus 2. That's right. Keep going. And remember, when you square root, you're going to get 2 answers. You're good so far. That's right. Okay. So now this is really u times u. So this is u squared. Keep going. So now factor in this one. Solve an equation. The original is x to the 4, right? So 4x plus or minus, plus or minus. Good? You get both? Good. Nice. Plus or minus, plus or minus. Good. I'm going to start putting up the answer. It looks like most of you have it. Now recognize that this first one is really x to the 4th, so it's like x squared times x squared. That's what makes the first one u squared. And then from there, it's pretty straightforward. So what you need to recognize is that you started x to the 4th, so you have to get 4 answers. That's your indicating factor that if you only got 2 answers, you forgot something, and a good amount of you forgot the plus or minuses. Okay, so think about when you're solving. This is an equation. This is an equation. You're solving an equation. When you do that, you take the principal root and the negative principal root, both. Okay, last one for the day. Now, looks really complicated, but it's not. Try to work through it and manipulate it so that it actually works for you here. Again, it's not the easiest problem. You can definitely do it. look at what you have squared. Think of the fact that you really can't change that and make the middle area work for what you have in the squared term. So that 2x minus 3 should be an indicating factor that that's probably going to be what your u is here. You can't change that. But you can change the middle. Like 10x, I can write that as 7x plus 3x. So I can write it as 8x plus 2x. Negative 19, I can write as 7 plus negative 26, or whatever else I'd like to. So manipulate it, please. Try to figure out what u is. This is the toughest one for sure. So far, so good. I like what you started with there. Great idea. Keep working with different numbers. Think about what you need to use. Anybody want to get in here? Hey, you want a 2x, don't you, somewhere? You need a 2x. And what do you have right now? How many x? 10. And if you take a 5 out, wouldn't you have a 2x? So think about the fact that if you made that 5 times parentheses 2x, then you got to do something with the 19. Think about the fact that if you break up the 19 into two numbers, you could then probably take out a 5 out of the middle terms there. So to give you a hint here, because 5 times 2x gives you 10, doesn't it? So I can put something here, and then leave a little blank here, plus something else maybe, or minus something else over here still. And leave yourself a little blank right there, something has to fill in also. How could you break up 19 so that you end up with the same middle term as the first term there? You're the best ones who did it. At least they did. Good. That's it. Very good. Now, to solve this though. Oh, you do it. Yeah, good. AC method. There it is. Good. So, for those that didn't get it yet, what needs to go here? What needs to go here? It has to. Minus 3 has to go there. Because this is only going to work if the middle term and the first term are the same thing. Only if these are the same, right? So if negative 3 goes there, what's 5 times negative 3? If I were to redistribute this out, this gives me 10x. What does this give me? And what do we really want, though? What was there to start with? Negative what? Not 15, negative 19. So how many are missing? So there should be a minus 4 still, right? So this blank, fill in the blank with minus 4. And now as a result, it's in quadratic form. If you don't believe me, check. Distribute out the 5. You'll get 10x minus 15 minus 4, which is minus 19. Okay, so again, that's why these can be a little bit tough. So when you practice tonight, this is the kind of thing you want to be working on. If those beginning problems are really simple, skip to the harder ones. Do the ones like this that are tougher. At this point, you can go through it. You're going to end up with 3u squared, right? So it's going to be a little bit difficult to factor. You might want to use AC method. Or I think, if I recall correctly, yeah, AC method I don't think works actually here. Did you try it?
Yeah, no,
It's not working, yeah. You have to use the quadratic formula. So let's do this one together actually. From this point on here. Okay, if I use the quadratic formula, it's always x equals negative b, but we have a u here. So u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If I continue down, I'm going to get u equals -5 plus or minus square root of, do I have a number? 73, I think it is. Yeah, there we go. All over 6. Now, at this point in time, we know that u was defined as 2x minus 3. We know that our answer is going to be what kind of a number? What kind of a number? Think about the discriminant from yesterday. The discriminant is 73. What kind of a number am I going to get for u?
Two positive, real, distinct. No, not real.
Two positive, real, distinct. What else? What's another label for it? They're both positive. There's two of them. They're real and they're distinct. What are they also going to be? Because it's a 73, not a 16.
Irrational.
Irrational. We know the answer is going to be irrational, right? So we could set each of these answers equal to 2x minus 3. It's going to be really annoying. This is one of those times where you give an approximate decimal value. Okay? So let's break this into two parts. U equals -5 plus root 73 over 6. U equals -5 minus root 73 over 6. Giving us answers of 0.59 and -2.26. Now, that's what u equals, but we have to remember we're not solving for u, we're solving for the unknown variable, which was x, and u was represented by 2x minus 3. So let's finish this problem off. Put 2x minus, whoops, didn't register on your iPad. 2x minus 3 here, and 2x minus 3 over here. Okay, and then solve both of these for x. They're both going to be positive for sure, we know that, because we're moving a 3 over. What do we get for our answers here? You're going to have to use your calculator, obviously, guys. What do you got?
X equals for the left side 1.795, and for the right side x equals 0.37.
0.37. Around it, yep. One thing to recognize, so a problem like this that happened to not work out with AC method in the end, probably would have been the same time to multiply it out in the beginning, right? If you went back to the beginning of this problem, and you looked at the original, and you just FOILed out the 2x minus 3, collected all your terms, and then just used the quadratic formula. In the end, for this one, it would be like you're not saving any time by doing it with this method. So you want to really recognize when it's applicable and when it's not to let u equal some term. So again, here, square the 2x minus 3, right? FOIL it out, distribute the 3 to everything, collect terms, and use the quadratic formula. You would get straight to the answers that we had here at the bottom. 1.795 and 0.37. Okay? Guys, you have homework from 7.4 and then some